Hey there, I'm St-Pierre, and you're listening to the Go podcast. Today I will talk about why I think Go is a great choice to build long-lived programs. Hello, Gophers. So it's been a long time since I posted an episode. I cut the COVID probably like 4 weeks ago, something like that, and I just started to feel better a little bit. This episode is basically 2 days. 2 days after I started to really feel bad. I was scheduled to talk on the Go Time podcast on legacy software, actually, and to be perfectly honest, it was very, very hard. So I thought that, I've listened to the episode back, and there's so many things that I did not talked about. I think this episode will be like me trying to talk about a little bit of legacy and how to why Go, in my opinion, is really a great language to try and limit the legacy aspect of software. The reason number one, in my opinion, why Go is a great language to build, long time software is the backward compatibility that the Go team announced in 2012 for the version 1. Basically, we will not introduce any breaking change and whatnot. But it goes more than that to me. So, and I don't want to bash or compare or say bad things about other languages and stacks and whatnot and frameworks. But it's not what my goal here is. My main point is that what I've seen, if I would encourage you to listen to the Go Time episode as well, because I will refer to some concepts. So if you do not, I will try to be brief. But basically, I'm currently maintaining like 20 years old software that were written in .NET, really early in the early stage of .NET. So more importantly than backward compatibility, I think, is the lack of framework for Go. And this, to me, is the highest selling point for the language. Basically, in my opinion, at least, I think what brings the most breaking changes from version to version, or let's say you have a piece of software that needs to survive 10, 15, 20 years. What is the what's the enemy is really frameworks. And in Go, if you don't use too many dependencies and things like that to build your application, it will just stand the test of time, because the standard library will not introduce any breaking change. At least we have not seen them too much so far. So I'm not sure if and when there will be a version 2. But for now, it's still like 10 years of promising a backward compatible. So it's incredible to have this stability. I think in software we I don't know where it came from, but as I'm getting older, I do appreciate longer living software or libraries. To me, it's not a problem to not have an update in the last 6 months or something. We don't need to add features and whatnot, and especially in languages, I think it just bloat the thing. So to me, the first reason why Go is great to build long-term software is this backward compatibility thing. The second reason I think is I need to put probably two things together, because I mean, so the fact that the testing engine is right there with the compiler and whatnot. You tend to, the Go community tend to write lots of tests, and ideally, maybe try to use the TDD approach. So that is something that I personally grow to love more and more. So I'm not coming from a huge testing background, if we can say that. So to me, the fact that Go the tooling is let's say that the format of the code is pretty much the same from one project to another. That is extremely interesting. I will come back to that in a bit. And the fact that the test is also very, it's just there. And yes, it's it make it very difficult to not use those things, because at the end of the day, so let's say you are building an application that will need to live long. At some point, you are not not really actively developing this thing. I mean, this thing. Let's say you wanted to build a web service that I don't know, was processing document. Let's say an ETL or some sort. So this service receive an input file. It could be anything: an Excel, a tab, a CSV, a fixed length, whatever. It applies some processing, some transformation and whatnot, and it just load the data somewhere. So at some point, this service will mostly be done, and there will not really be any active development on it. So it might happen that 2 years can pass and no one have touched this thing. And the fact that the code, so there is a bug that occurs in that thing 2 years later. So even someone that was not involved in the development of this thing will be able to jump right in, because the code is very familiar. The code is the formatting, the packages and whatnot. So I mean, it will have some kind of continuity with the other project at the organization and things like that. So the test that should run as is directly. So the developer that needs to fix the bug, they would basically just clone that thing, run the test, and I mean, there's no friction. If you take a JavaScript application, for example, and you let it there for 2-3 years, and you decide at some point to clone it back and install the package and try to see if things are running. Maybe they will have some some small interesting aspect, mostly regarding the build system and whatnot. But my point is, the fact that everything is there, built in, and really quickly standard from one project to another makes makes returning to a code base easier. The last reason why I think Go programs can survive longer is the simplicity of the code. It might be overlooked, and it's certainly not the most sexiest things in regarding programming and whatnot. If you compare to languages like Rust or Erlang, Elixir, for example, where let's just talk about functional programming for a second. So indeed, functional programming allows you to express yourself as a programmer in lots of ways and things like that. But I also believe that it can be hard, even if you are the one that wrote a specific function, it can be hard at times to return back to the code and really make sense of what's going on here. You might need a couple of, you might need to reprocess the same thought process that the original author of the code needed to write that in order to really understand what's going on there. So that's something that is not there in Go. So in Go, the construct of the language are so simple that it's a good thing and it's a bad thing for some people. And sometimes it feels like it's extremely verbose and things like that. And we will have to see exactly what the generics will bring. Will they bring lots of more complexity? So we might have lost a little bit of simplicity. So yeah, to me, simplicity is winning over expressiveness. Again, it depends what you are building, but I'm talking again in a context where a program will need to live 15, 20 years. In 20 years, I don't want to open something and have 1 week to examine a module and understand what was going on here. Even if you have tests, even all of that. So I think the code simplicity is probably it's Go is probably the language that I've seen so far that have it is the most simple. I would say the same for C, but C is also complex sometimes due to all the memory management and whatnot. So this is something that Go removed with the garbage collector. So it's a simple language. It's just the syntax and whatnot. So I think this contributes to making sure that it should be straightforward to just recompile and understand a program after a long time it is running. So yeah, I hope you like this episode. That's it for today. All right, that's it for this week. I hope you liked the episode. And again, if you can share and talk about the podcast, that would be extremely appreciated. Also, if you want to check my book out, I have a course named Build SaaS App in Go. So it's at buildsasappingo.com. All right, see you in 2 weeks. Bye.